Dear students, welcome back to the course Embedded System. Hope you are clear with ARM-based microcontroller. In this session we are going to discuss about Introduction to Embedded System Architecture, and classifications of embedded systems. Let we see what is an embedded system. A system is an arrangement in which all its units assemble work together, according to a set of rules. It can also be defined as a way of working, organizing, or doing one or many tasks, according to a fixed plan. For example, a watch is a time displaying system. Its components follow a set of rules to show time. If one of its parts fails, the watch will stop working. So we can say, in a system, all its subcomponents depend on each other. As its name suggests, embedded means something that is attached to another thing. An embedded system can be thought of as a computer hardware system, having software embedded in it. An embedded system can be an independent system, or it can be a part of a large system. An embedded system is a microcontroller, or microprocessor-based system, which is designed to perform a specific task. Simply we can say that it's a combination of both hardware and software to do some specific task. For example, a fire alarm is an embedded system, it will sense only smoke. Consider a washing machine and it is an automatic clothes washing system. So an embedded system will perform some specific task. The major components of embedded systems are hardware, and an application software, and real-time operating system, RTOS, that supervises the application software, and provide mechanism to let the processor run a process, as per scheduling, by following a plan to control the latencies. RTOS defines the way the system works. It sets the rules during the execution of application program. A small-scale embedded system may not have RTOS. So we can define an embedded system as a microcontroller-based, software-driven, reliable, real-time control system. Let's watch this video for embedded applications in our day-to-day life. Let's see what is computer. A computer is a system that has the following three components. A microprocessor. A large memory of the following two kinds. One is primary memory, or semiconductor memories. They are RAM, ROM, and fast accessible caches. Second one is secondary memory, or magnetic memory located in hard disks, diskettes, and cartridge tapes, optical memory in CD-ROM, or memory stick, in mobile computer, using which different user programs can load into the primary memory and can be run. Input and output units, such as touch screen, modem, fax com modem, etc. Input units such as keyboard, mouse, digitizer, scanner, etc. Output units like LCD screen, video monitor, printer, etc. Networking units like Ethernet card, front-end processor-based server, bus drivers, etc. Operating system, OS. General-purpose user interfaces, and application software, mostly in secondary memory. Now consider an embedded system. An embedded system is a system that has three main components embedded into it. It embeds hardware to give computer-like functionalities. It embeds main application software, generally into flash, or ROM. And the application software which performs the number of tasks concurrently. It embeds a real-time operating system, RTOS, which supervises the application software tasks running on the hardware, and organizes the accesses to system resources, according to priorities and timing constraints of tasks in the system. It provides a mechanism to let the processor run each process, as per scheduling and, to do context switch between the various processes like threads or tasks. RTOS sets the rules during execution of application processes, to enable finishing of a process within the assigned time interval, and with assigned priority. Let we differentiate embedded systems and general computing systems. An embedded system is a combination of special-purpose hardware and embedded OS for executing a specific set of applications. But a general-purpose computing system is a combination of generic hardware and general-purpose operating system, for executing a variety of applications. An embedded system may or may not contain an operating system for functioning, but GPCs contain a general-purpose operating system. The firmware of the embedded system is pre-programmed and it is non-alterable by end user. But in a general-purpose computing system the applications are alterable or programmable by user. It is possible for the end user to reinstall the operating system, and add or remove user applications. Application-specific requirements, like performance, power requirements, memory usage etc., are the key deciding factors of any embedded system. Performance is the key deciding factor on the selection of the general-purpose computing system. Always faster is better. For certain category of embedded systems like mission-critical systems, the response time requirement is highly critical. Response requirements are not time-critical in general-purpose computing system. Next is the characteristics of embedded system. Unlike general-purpose computing systems, embedded systems possess certain specific characteristics, and these characteristics are unique to each embedded system. Speed should be high. Dissipate low power. Small in size and low weight. Must be very accurate. High adaptability and accessibility. Must be reliable over a long period of time. So, an embedded system must perform the operations at a high speed, so that it can be readily used for real-time applications, and its power consumption must be very low, and the size of the system should be as far as possible small, and the readings must be accurate with minimum error. The system must be easily adaptable for different situations. The hardware components of embedded system are shown in this figure. The embedded system hardware includes elements like user interface, input/output interfaces, display and memory, etc. Generally, an embedded system comprises power supply, processor, memory, timers, serial communication ports and system application-specific circuits. A processor is an important unit in the embedded system hardware. It is the heart of the embedded system. It is the basic unit that takes inputs and produces an output after processing the data. Knowledge of basic concept of microprocessor and microcontroller is must for an embedded system designer. Processor has two essential units: program flow control unit, and execution unit. The control unit includes a fetch unit for fetching instructions from the memory. The execution unit has circuits that implement the instructions pertaining to data transfer operation, and data conversion from one form to another. The EU includes the arithmetic and logical unit, ALU, and also the circuits that execute instructions for a program control task, such as interrupt, or jump to another set of instructions. A processor runs the cycles of fetch and executes the instructions in the same sequence, as they are fetched from memory. The power supply is an essential part of any embedded system's circuits. An embedded system may need a supply of 5 volts, or if it is low power then maybe 3.3 or 1.8 volts. The supply may be provided with the help of battery, or we can use any wall adapter. It will depend on the application need. Most systems have a power supply of their own. The network interface card and graphic accelerator are examples of embedded system that do not have their own power supply, and connect to PC power supply lines. Charge pump concept used in a system of little power needs, for examples, in the mouse or contactless smart card. Most of the embedded systems nowadays work on battery-operated supplies. Because low power dissipation is always required. Hence the systems are designed to work with batteries. The clock controls the time for executing an instruction. After the power supply, the clock is the basic unit of a system. A processor needs a clock oscillator circuit. The clock controls the various clocking requirements of the CPU, system timers, and the CPU machine cycles. The machine cycles are used for fetching codes, data from memory, and then decoding and executing them at the processor, for transferring the results to memory. If you are working in embedded systems, you must have heard about. What are timer and counter? Why we use timer and counter? What is difference between timers and counter? In some application, we need to generate some delay. Like for blinking an LED, we need a delay. For making square pulse we need a delay. For such kind of application where we need a delay for a specific time interval without affecting the normal code execution, we use timer and counter. Timer circuit is suitably configured as the system clock, which ticks and generates system interrupts periodically. A timer is a circuit is suitably configured as the real-time clock, that generates system interrupts periodically for the schedulers, real-time programs and for periodic saving of time and date in the system. To schedule the various tasks, and for real-time programming system clock is needed. The clock also derives the timers for various timing and counting needs in a system. Next is reset circuit. Reset means that processor begins processing of instructions from starting address, set by default in program counter on power up. If we are using a microcontroller, like AT89S51, AT89S52, or ATmega, the memory is available on chip. We generally talk about two types of memory in the embedded systems. Read-only memory or RAM. Random access memory or ROM. Electrically erasable programmable read-only memory, EEPROM. RAM memory is volatile memory and used for temporary storage of the data. And the selection of it depends on the user need and the application. The ROM memory or code memory. This is used for the storage of the program. Once system powered, the system fetches the code from the ROM memory. The EEPROM is a unique memory. The content can be erased and reprogrammed by a high-voltage pulse input. This is used to store the data by the program itself. Suppose we have a temperature data logger. And it needs to store the data every 1 hour. It means we need the data at runtime after the system is started. The system will read temperature and store in the EEPROM memory. And it will be permanent. And you can retrieve the data later. To interact with the embedded systems we need input. The input may be provided by the user or by some sensor. Sometimes some systems need more input or output. So the processor selection will be based on I/O. The I/O need to be configured for input or output based on the provided register. And for that, we need to refer the datasheet of the manufacturer. Some hardware components are common while designing the embedded systems. But some are different and depends on the application need. Like a temperature sensor for sensing or measuring the temperature. While others hand an alcohol detector has a sensor to detect the alcohol level. But the remaining hardware components might be the same, like power supply, processor, display device, buzzer for alert. We know that an embedded system is a combination of both hardware and software. For programming the hardware, we need a program written in assembly or in embedded C language. And then we compile it. This compiled code converted into hex code. This hex code is programmed or burned into the ROM of the system, using some programmer. These are the tools that are generally used in embedded system development: assembler, emulator, debugger, compiler. When you program in assembly language, this assembly language program is converted into the hex code using this utility. Then using some hardware called as a programmer, we write the chip. An emulator is hardware or software tool that has a similar functionality to the target system or guest system. It enables the host system to execute the functionality and other components. It is a replica of the target system and used for debugging the code and issues. Once program or code is fixed at the host system, it is transferred to the target system. Sometimes we are not getting expected results or output due to errors or bug. There are certain tools that are specifically used for the debugging process, where we can see the controls flow and register value to identify the issue. A compiler is a software tool that converts one programming language into target code that a machine can understand. The compiler basically used for translating the high-level language into the low-level language like machine code, assembly language or object code. Students, watch this video regarding embedded system and its applications. Next we are going to learn about classification of embedded system. Embedded systems can be classified based on the performance and functional requirements and the performance of the microcontroller. Embedded systems can be classified into 4 types, based on the performance and functional requirement. They are real-time embedded systems, standalone embedded systems, networked embedded systems, mobile embedded systems. Based on the microcontroller performance, it can be classified to 3 types. They are small-scale embedded systems, medium-scale embedded systems, sophisticated embedded systems. A standalone embedded system works by itself. It is a self-contained device, which does not require any host system like a computer. It takes either digital or analog inputs from its input ports, calibrates, converts, and processes the data, and outputs the resulting data to its attached output device, which either displays data or controls and drives the attached devices. Examples are temperature measurement systems, video game consoles, MP3 players, digital cameras, and microwave ovens are the examples for this category. Next one is real-time embedded system. An embedded system, which gives the required output in a specified time, or which strictly follows the time deadlines for completion of a task, is known as real-time system. That is, a real-time system, in addition to functional correctness, also satisfies the time constraints. There are two types of real-time systems. First one is soft real-time system and second is hard real-time system. Let we see what is soft real-time system. A real-time system in which the violation of time constraints will cause only the degraded quality, but the system can continue to operate, is known as a soft real-time system. In soft real-time systems, the design focus is to offer a guaranteed bandwidth to each real-time task, and to distribute the resources to the tasks. Example: a microwave oven, washing machine, TV remote, etc. A real-time system in which the violation of time constraints will cause critical failure, and loss of life, or property damage or catastrophe, is known as a hard real-time system. These systems usually interact directly with physical hardware, instead of through a human being. The hardware and software of hard real-time systems must allow a worst-case execution analysis that guarantees the execution be completed within a strict deadline. The chip selection and RTOS selection become important factors for hard real-time system design. Example: deadline in a missile control embedded system, delayed alarm during a gas leakage, car airbag control system, a delayed response in pacemakers, failure in radar functioning, etc. The portable embedded devices like mobile and cellular phones, digital cameras, MP3 players, PDA, personal digital assistants, are the example for mobile embedded systems. The basic limitation of these devices is memory and other resources. The networked embedded systems are related to a network with network interfaces to access the resources. The connected network can be a local area network, or a wide area network, or the Internet. The connection can be either wired or wireless. The networked embedded system is the fastest growing area in embedded systems applications. A home security system is an example of a LAN networked embedded system, where all sensors, example motion detectors, light sensors, or smoke sensors, are wired and running on the TCP/IP protocol. Let's watch a video of embedded applications in security system. Based on the performance of the microcontroller, they are also classified into small-scaled embedded system, medium-scaled embedded system and large-scaled embedded system. An embedded system supported by a single 80R16-bit microcontroller with on-chip RAM and ROM designed to perform simple tasks is a small-scale embedded system. Example is Electron toy. An embedded system supported by 16 or 32-bit microcontroller or microprocessor, with external RAM and ROM, that can perform more complex operations is a medium-scale embedded system. An embedded system supported by 32 or 64-bit multiple chips, which can perform distributed jobs, is considered as a large-scale embedded system. Dear students, in this session we discussed about what is embedded system, hardware and software architecture and classification of embedded system. Hope you are clear with this concept. Thank you.